In this example, we have a couple of equivalent matrices here. Each of these matrices has 2 rows and a single column, which means that their corresponding entries will be equal to one another. So what we can do is go ahead and set up a system of equations, and then we can solve that system to go ahead and find the values for x and y that make this equation true. So in the first row, we can see that 2x minus y equals 3. And in the second row, we see that 9 equals 2y minus x. So we have a nice system here that we can solve. And it looks like maybe substitution might be a good way to go. Let's go ahead and solve for this x maybe here in the second equation. So we could take this negative x and push him over to the left side to make him a positive x. And then this positive 9 we could bring over to the right side by subtracting 9 from both sides. And it looks like we have x equals 2y minus 9. So let's go ahead and take this expression, this 2y minus 9, which is equivalent to x, and let's go ahead and substitute him in for x, but in the other equation. So we'll use this first equation. So 2 times x, and we know x is this expression, 2y minus 9, and when we subtract y from that, we get 3. Okay, so it's just using this first equation, we substituted this 2y minus 9 into it. Okay, so basically now it's just solve for y. So we'll distribute first, and we see that 4y minus 18 minus y equals 3. So when I combine these like terms, we have 4y minus y, so that'll be 3y. And I'll also add 18 to both sides while I'm at it. So I see that 3y equals 21. So when I divide both sides by 3 now, it looks like my value for y is going to be 7. Well, once I know that value for y, I can go ahead and plug it back in. Let's go ahead and plug it in right here because x is already isolated. So x equals twice the y value minus 9. So it looks like x equals 14 minus 9, so that's going to be 5. Okay, well let's go ahead and just plug these values back into our original equation and just kind of ensure that they work. So we said that the x value was 5, and we said the y value was 7. So twice x, so 2 times 5 is 10. 10 minus 7 is 3, and 3, yeah, does equal 3, okay? So 2 times the y value, so 2 times 7 is 14, minus 5 is 9, and 9 equals 9. So it looks like we're good to go. So in this example, we went ahead and used the fact that these matrices were equivalent matrices, and we were able to set up equations using the corresponding entries, and we solved this system that we ended up getting, and we see that x is 5 and y is 7.